there give you... So I just added the 3 over, right? So what do you have to put here? How do you work completing the square?
25 fourths.
Yeah, exactly, because you take half of this, step 1. Step 2 is you square that bad boy. That's what you put here, and the minute you put it there, you gotta put it over there too. Can't change one side of an equation. And then this tells you how this piece works back. Cool. And what do you get over there?
Like 51 fourths, I think.
I got 51 fourths.
Try again.
I got 51.
That's good. Try again. I know 30 and 20 is 50, but 6 and 5 is 11, right? Okay, don't scare me like that this early in the morning. My 88 class. So then what's the center? 0, negative 5 halves. And then what's the radius?
Square root of 61 over 2.
Good. Square root of 61 over 2, because square root of 4 is 2. Sweet. Okay, cool. Cool. Okay. Is that cool?
So you'd be fine with that? That was on the test. You would want the approximate answer.
No.
No, it shouldn't be wrong.
Yeah. Yes.
D on number 6.
Oh yeah. Okay. So I like the fact that some of you guys in the homework you're doing, like I suggested, if I give you a function and I ask you to do this difference quotient, you see this popping up every now and then. I told you you're going to see it in calculus too. And a decent number of you guys are going into calculus. So what's g of x plus h?
3 over x plus 8.
3 over x plus h. Exactly. Just plug that in. So I want to plug in g of x plus h minus g of x all over h. So that's this. That's this. And then, of course, you get there and you're like, the hell, man. But the trick, the clue here is I have fractions inside of fractions. Normally, when I have that, I want to kill some of those fractions, right? It's just doing a freaking inception fraction thing, right? Yes, sir?
Are we done with that already?
Oh,
Okay.
how do I continue with this?
Get a common denominator.
Good. Get a common denominator. Common denominator. So this guy needs x. No, this guy needs x. This guy needs x plus h. Now, did I actually do anything to the top just now? I didn't do shit to the top. I just made it look different. It's the same exact thing it was. I don't have to do anything to the bottom. I didn't do anything to the top yet. Now, there's 2 ways to go from here. You can multiply top and bottom by the LCD. Or it can be a little smarter. On the top, I can put these together, right? And what's on the bottom? This and this. Because I'm dividing by both of these things. So I get h, x plus h. I'll let you guys soak that in.
Wait, really?
Can we run through that one more time?
Yeah, real quick. In general, if I had 3 over 2 over 7, how do you simplify that?
So you just bring 7 times 2?
Why? This is 3 over 2 divided by 7, which is 3 over 2 times 1/7. So when I do that shit, we just put those and make it 14, right? So I've got this being divided by this and this, and let's just represent that in a single sweat. Swell swoop. Fell swoop. There it is. And then how do I continue from there? Just a couple more steps. 3x minus 3x minus 3h.
hx squared plus h squared x.
Yeah, don't worry about multiplying that out, please. So kill those, the h dies, so you get negative 3 over x times x plus h.
Why do you want to differ around? They're still got the same thing.
Sweet. I like it. So if you guys get to calculus, you will be doing exactly that, except you'll have one more step after that. Yes?
Alright, I was just curious, for B, when they say 0 F, do you just plug in 0?
Yeah, the 0 of a function is when the function is 0.
Okay.
It's not f of 0. So be really careful. Yeah.
Could we check just the graph on number 5? I was just curious if I did it right.
I tell you, well, I got the key. So, let me do this. I'll just go ahead and give it to you guys. Let me say this. This is some of you guys' first receiving of a key from me. So don't do this. Yeah. Yeah. Don't agree with me. They didn't do anything for you. You understand what I'm saying? So either do the thing and then look at the key, or never look at either one. I mean, it's just not going to do you any good to go, yeah, that's what I would have done. Yeah. Yeah, how do you know? All right, so be really careful about that. It's always easier to agree with me than to do it. And I've definitely been known to make mistakes, mainly because I'm human. And that is the definition of being human. This is really warm in here, isn't it?
Yeah.
I tried to do something with the thermostat, but it's some of these are just decoration to make you feel better. So it might just be decoration. So number 5, did I do the? Yes. Okay. So let me do this. Let me say this. I didn't do this on there. I was worried. On the homework, on the quiz, on the test, anything that you're doing, if I ask you to do a transform of something, I want you to list the transforms. Right? List what's happening. Reflection, moves left to, whatever. And that's good. Right? At least list the transforms and then show me a couple of steps on the graph. Right? Don't just go straight to the end result, because I don't know where that would have come from. I told you, I got nothing. Yes?
I had a homework question.
Yes?
2.6, 166.
Oh yeah, this looks yummy. Let's see. 66. This is page 198. This one says an airplane is flying at a speed of 350 miles an hour at an altitude of 1 mile. $350 miles an hour. The plane passes directly above a radar station at time t equals 0. So, but some later time t, it's over here. Right? So they label the picture D there and S here. So here's the idea. At time t equals 0, it's right there. So it's a mile away from this station or whatever, right? And then they want to know, well, at some later time t, what's this distance here going to be? How far away is it now? It's not a mile anymore. It's a little more than a mile away, right? So express the distance s between the plane and the radar station as a function of the horizontal distance d. Now that just sounds crazy, but I want s as a function of d. So of course, what's the rule of the day here with this shape? Thing right there. Exactly. I'm interested in the sides of this thing. I know it's right triangle because this plane's flying perpendicular to the ground. So how do and what's nice about S? That's the what of the triangle? Hypotenuse. So what's the Theremin theorem say? Okay, a squared plus b squared equals c squared. Where's s definitely got to go?
C squared.
C. And then the other ones can go whatever they want because it doesn't matter. What do I put over there?
D squared.
1 plus d squared, 11. It's not quite what they want, though. They want s as a function of d. I have s squared as a function of d, so I just have to...
Square root it.
And what do you not have to worry about here because we're talking about physical distance?
Well, you don't have to worry about plus or minus.
Don't have to worry about plus or minus. It's got to be plus, right? Plane's not getting sucked into some black hole, hopefully. That would get weird. You're sorry you got sucked into a black hole. Please accept these miles for the next trip. Alright, so that's part A. Part A, S as a function of D. Sweet. And then part B says, express D as a function of the time.
So you're just working backwards to make D.
D.
No, be careful. B has not a damn thing in the world to do with part A.
No, I'm talking about D.
So part B, what about?
Like, to get D is equal to...
Yes. So what is distance in general equal to if I know?
Rate times time.
Yeah, rate times time. And what's the rate?
350 miles an
There you
hour.
go, 350 t. Done with part B. So people make too much out of part B. Part B is just dirt. Right? And you just throw in the velocity they gave you. Yeah, Chris.
Can you do 2F on the practice test?
I can, as soon as we're done with this. What about part C? Use composition to express S as a function of T. So S is currently a function of D, and D is a function of... D is a function of
Rate times time.
T. I only see T there, right? I see a number times T. You kind of with me? So S is a function of D. D is a function of T. So I want to write S as a function of time. So that's kind of, I can do that. F of D of T. I just have to throw the that inside of that. That's what they mean by use composition to do it. If S is a function of D, but D itself is a function of T, I just got to throw it in. Do you guys see that? Yes. Okay. So if I had a different plane in the same situation, I was traveling at a different speed, I would have a different function here once I threw the new speed in, right?
Just substituting it.
I'm just substituting that whole function into that one. Cool. That's what they mean by use composition. Composition when you put a whole function inside of another function. So it sounds horrible, but all you got to do is throw that there. So then what do you get for this? You get S equals square root of 1 plus 350t squared. And you just got to figure out what 350 squared is. Okay, cool. Those ones at the end are always a little weird. What's up? Oh yeah, Chris, what's up?
2F. I think you can refer to what you did on this side.
Yeah, I forgot to factor 3, didn't I?
Well, you could do that, and then you could kill the x minus 3. 3's can go to 1 or negative 1.
Yeah, good. All right. So take in what I got to there. 2f. From the very beginning, actually, there's something I could have done right here. If I factor this, then I get 3x minus 3. And of course, here I get...
X minus 3.
What can I do here?
Kill the 3.
Kill the 3. Good. Good. So now what's he need that he's got? He's x plus 3. Cool. And does he need anything? No. So then I get x plus 3 minus 2x all over x minus 3x plus 3. Cool. And then, yeah, because there's negative x plus 3. And then there's one more thing you can do.
Negative 1. Pull it out.
Good. Take a negative 1 out of the top. Whenever you have something that looks like it wants to go away, but they're just offset by a negative, factor a negative out. If I take a negative 1 out of the top, what do I get?
X minus
Positive x minus 3. And then you get one over x. Cool. So that should be 2f. That should be where you stop. Cool. I'm still averaging about a 97 on my answer keys. It's not too bad. All right. Anything else from homework or yes?
Can you explain how the ones like number 54 on 2.6, where it says express the function on the average?
Oh, I like it. Good. That's exactly the question I expect. There's certain questions that if I don't get them, I'm worried that nobody's doing the homework. Because I'm like, good God, I didn't say a damn thing about that. So where the hell is the question? Good. Already made me feel better. What's up?
Well, 57 might be better.
Well, let's start with 54. It's only got 2 levels, right? This is 54 from the homework, 2.6. So what you're trying to do is you're trying to do this composition backwards. You're trying to say, where did this big ass h of x come from? I want to write big ass h of x as f of g of x. So, do you guys, there's actually several different correct answers. Do you guys see a function that's inside another function here? So what would you call g? What's the inside function? Alright, good. That's one way to do it.
Or it could be...
And what would, no, go on with this. What would your f of x be? What is that inside of? Say again?
Square root of 1 plus x.
Kick ass. If you plug that in there, you get this, right?
Yeah.
Does somebody have a different answer?
Yeah, you could just add a...
What's inside? What's the inside function here? What's the inside function? This whole thing, right? So I'd say, another way to say this is one way to do it. A second way to do this is if I call the inside function the whole inside, well, what would f of x have to be?
Square root of x.
Yes, if I plug that in there, I get this. Yes, that's what I mean. There's more than one answer for these things.
Are more many?
Oh, hell yeah. If you put 2 functions together, if you put one function inside another function, you result in something. It didn't only have to come from there. It could have come from something else. Let me see. What's another? The next set wants you to do 3 levels, right? Which is like Inception, the sequel. Well, actually, how many levels was in freaking Inception? I still don't know. I gotta watch it with a notebook next time. Huh? I don't know,
No,
man.
at the end, I think
Just who's? Is anybody awake in this thing? What's going on? If you haven't seen it, maybe keep it like that. It might be better. Let's look. 56. Well, let's do one that's very different. 55. I like 55. So I got big ass F. So now they want you to write this as big ass F. It's F of G of H. They want you to write it in 3 levels. So a function inside another function inside another function, right? Aw. Yes, sir.
There's 2 f's though. How does that?
Big ass F and little f.
Oh. So
Yeah, that's why I kept calling it big ass F, because he's different than little ass F. It's true, actually, in mathematics. We look at the capital and the lower. Because believe it or not, sometimes you have to run through the whole damn alphabet and start over again. Lowercase. I like the face. Yes.
I just got an idea for this.
Okay.
So h of x would be x squared.
Okay, h of x could be x squared.
G could be x plus 1.
G of x could be x plus 1.
And your f of x would be 1 over x.
Alright, let's check it out. It seems to make sense, because it looks like the outer function should be 1 over something, right? That's the general formula. This is 1 over something. So if I call h of x x squared, if I plug it into this, g of h is what? X squared plus 1. And if I plug that in here, I do get that. Cool. Kicking the ass. So you can you take a guess, get a little guess, and then you can just check it out. Make sure it actually ends up where it's supposed to end up. I'm not saying those problems are easy, but I am saying you have a plan of attack here. You can kind of try something, you can see why it doesn't work, and you can make a little adjustment. Going backwards is always harder. Yeah.
So with those, you always want to type it from the inside out.
Pretty much, because the whole idea of composition is there's an inside function that's in something else. So if I had a function that was like the cube root of x squared minus 1 over x, I would say the outside function is the cube root.
Yeah.
And the inside functions would be some composition that give me this, right? There's a definite outside and there's a definite inside. And the more you understand that, now the easier parts of calculus will be too. It's crazy how they named this class appropriately. Yes?
I have a lot of questions.
Okay.
24 from 2.7.
Oh yeah, I like it. Cool. Alright, so this is another weird looking one. So they give me that g of x is x squared plus 4x. This is 24 in section 2.7. X is greater than or equal to negative 2. Now why do they have to say this?
Because x squared is a parabola.
Good, because this would not by itself be...
It wouldn't be
invertible.
Wouldn't be invertible, wouldn't be 1-to-1, right? Because it doesn't pass the horizontal line test. But if I restrict the domain, they cut it. Hopefully they cut it correctly, so now it does pass the horizontal line test. We talked about that last time. All right, maybe. That's why that's there. Find G inverse of 5. Now, I want to give you a way to look at this. If G inverse... Let me see how I can say this. I could switch the x and y and do all kind of business like we did before to find an inverse, right? But since I'm working with G kind of directly, G's the only thing I know. G inverse, I'd say its inputs are y's and its outputs are x's. Is that cool? Just if I want to keep everything in terms of what this guy does. His inputs are x's, so my inverse's outputs are x's. So what this says is, G inverse of 5 is what? Right? And you're all like, wow, that makes it so clear now. Good job. No. So what I can do now this is kind of cool. I want you guys to stay with me. This is just a way you can look at this. What this is really asking is, what x for this gives me 5 as an output? Right? Because remember, what's the input of an inverse? The output of the function itself. So what this really says is, when is the output 5? For what x is the output 5?
So you just have to plug in
include
y
for G of x.
I mean,
5. Make x.
You can't plug a 5 into G of x, hell no.
You make
No,
x squared plus
equals.
4x equals 5.
Exactly, you make your x squared, if that's what you're saying, then you're okay. Make x squared plus 4x has to equal 5. You want to know, when is the output 5?
And you factor that.
Factor that and be careful about this restriction, right?
Well, that's how you know what to throw out.
Good.
negative 5 plus 1.
Because real quick, the thing I was going to do with this is, let me see if you guys can see this. So another way to get there is I can, okay, here we go. You ready? I can take G of both sides. Why am I allowed to do that? Because as long as I do it to both sides,
They cancel.
that's why I'm doing this specifically. But why am I allowed to do this in the first place? Because I'm doing it to both sides of the equation, right? I could put freaking H on both sides, but it's not going to do a damn thing for me, so screw H. These two cancel, so I get 5 equals G of x, and what's G of x? So I get this. That's where that came from, really. You have to go there. You don't have to go all the way there. All you have to realize is what this is really asking is, what makes an output of 5 for this? Because this guy's inputs are this guy's outputs. So this question by itself is, when does G have an output of 5? And then you say, when does G have an output of 5? Bam, you solve it. Cool. You get one that works and one that doesn't because, again, the restriction, right? Because how do you solve this? You guys are still looking at me like I'm crazy.
Factor.
Yeah, it's subtract 5, factor it, yeah. Okay.
I have a question on practice test number 5.
Yes.
With the domain and ranges of these.
What's up?
With the domain and ranges of these, it's on page 189.
Yes.
Since the, I don't think these confused, ranges is up and down, right?
Yes. Cool.
So with those then, since there's no, I mean, you can take a pretty good guess on the graph that's given, that you can make them brackets as far as the range goes, but they're not exact like the filled in dots are.
Well, the dots you have to fill in because those are the true endpoints. Middle points you don't really have to. So you can make an argument for any of these graphs that it's not clear exactly where that goes. But the assumption made here is if they're not specific, they understand it to end at a whole number. So it definitely goes to that whole number there, so I'm going to include that also in the range. Yeah?
So let's say you have an execute function, and they're asking for a local min and local max. There is none, right? There's only global min
Good.
and global max.
I like it. Execute function, there's no local max or min, because the local max or min happens where what happens? A max is anywhere that it goes like that, and a min is anywhere that it goes like that, right? And of course a cubic function goes, no, I'm not going to turn. Right? So there's no max for any odd, x of fifth, all that kind of stuff. Max or min. Yeah, the answer for a max or min question is never an infinity. Never. Because that would be like an unbounded. That would mean that there is no maximum. Because you can't get to infinity, so you can't say the maximum is infinity.
And you give it as a specific point, like the answer, like a
Okay, I like you're asking that question. I wasn't overly critical on the homework, but you do have to be careful. When they say, what is the max value? That is the y, that's the output. When they say, where does the max occur? That's the x value. X's are always where things happen, and y's are what the hell happened, right? Okay, yes?
Number 20 on 2.6.
Okay. This is really just a practice of using the graphic calculator. So, let's see. No, I don't want to turn you off. I want to turn you off. Okay. I'll let you guys see my password so you can't get my pictures out in the cloud. That's really funny. I saw a cartoon or comics with Groot from Guardians of the Galaxy.
Oh, yeah.
You seen it?
Yeah.
Maybe you should have made your password I am Groot.
Yeah.
It might not be the best. Alright. So as normal, just half you guys have no idea what the hell I'm talking about. But let's go back to math.
We saw that Apple came out with a statement saying it was in the cloud, and the investigators think that they got it from the Emmys.
Yeah,
They
I
got it
heard
from
that
the
they
Emmys
thought they
Wi-Fi.
got it there. And then the Apple had a problem. They had a bug where you could put as many password attempts as you wanted to. There was no limit. There was like a bug in their system. They're saying that's not what affected it here, but that would make sense.
Yeah.
Because then you just hook up you could do Terminator 2 to it, just throw a bunch of freaking passwords at it. Alright, enough of that, sorry. So here it says, plot the functions and their sum. So the functions they give me are the fourth root of 1 minus x. So a really good question is, how the hell do you graph the fourth root of 1 minus x?
1 minus x.
Yeah, 1 minus x.
Greatest thing in the internet.
No.
To the power of
To the
Power of 1 divided by 4.
Good. Because a fourth root is a 1/4 power. There you go. Problem solved. Now, so you guys, just to show you, there is what I call a fruit button. See right there, number 5. So another way to say the fourth root is to say the fourth root. Alright, that's enough of that. 1 minus x, and that's the same way to say what I've already got up here. You guys with me?
Yeah.
So here's the root button, but there's also, you just make it a 1/4 power. That's a fourth root. It doesn't matter which way you do it. And the other function is square root of 1 minus, no, just 1 minus x squared divided by 9. Okay. How are we doing so far? So just plug those in. And it says, blah, 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 and f plus g. And I want to show you, now you could put this whole thing again plus this, right? I mean, that's f plus g. F plus g would be this plus that. You with me?
Yeah.
I want to show you something kind of neat. You don't have to remember this, by the way. I just want to show you today. See where it says vars? Variables? If you go to vars and go over to y vars, you can actually refer to y1 and y2. See them? So I can say y1 plus vars, y vars, function y2. So now it's going to give me y1 plus y2. So now I have to type all that root stuff in again.
Wait, how do you do that again?
You go to vars, y vars, y variables, right? The function refers to what you put in here. See, if you hit enter, you get y1, y2, y3. And what's y1? This. What's y2? This. So what's y1 plus y2? F plus g. So if I graph, now hit zoom 6 whenever you put the new stuff in, just to get back to a standard screen. So that's y1. That's the fourth root. Yeah, and y2, that's the square root, and there's y3.
Whoa.
So look at, where's all the action happening? Right there, right?
Intersect.
And then I can't see any of that. That looks, what the hell? It's an abstract paint. So hit zoom box is one of my favorite things. Zoom box. You go up and over, and when you move the cursor and hit enter, that's one corner of the box. Now you hit down and over. This is like CSI enhanced, right? I can see the killer's face in the reflection. So there's y1. There's the fourth root. And there's y2. There's the square root one. And then there's the sum. And of course, see how the sum starts where that one starts and ends where that one ends? Because it's got to exist where they both exist. And since it's a sum, it's always going to be bigger than both, except right there, that's a 0. 0 plus this stays right in the same place. Are you guys kind of with me?
Yes.
So you're adding this function to this function, and you're getting this guy, and it only exists where both of those exist. That's what I was talking about. Whenever you have f plus g, the domain is going to be only those things that work in both. So it's only going to be where both exist, of course. Because what's 1 plus does not exist? I don't know. You guys semi with me. So that's what they're asking you to do in your calculator. y1 is f, y2 is g, y3 is f plus g. And just see what it looks like. And what are they asking about? Or they just say, look at it. Alright, so that's basically, It'd be nice if you gave me a little, It'd be nice if you gave me a little quick, rough sketch whenever you do a graphing calculator problem. But really, it's sort of honor system. Just if you don't do this problem, you're getting less practice with your graphing calculator. You're going to die when I ask you a question on the test, right? Okay. Is that good for that problem? Okay. Yes.
35 on 2.7.
Oh, okay. So, if I thought, let's see who remembers this. If I thought that f of x and g of x, I think that they are inverses of each other. How do I check real quick?
So you put them in together. And
Good. If I put g into f, if they are inverses, what should I get out?
X.
Beautiful. Just try one of these. So they say, verify that these are inverses. So I know this should work. Which one are we looking at again?
35.
35. Yeah, that looks yummy.
Let's see.
Now, rational functions are very weird as far as their inverses. I wouldn't just look at that and go, oh yeah, it's the inverse, right? It's easy with a cube root, and you see a cube, and you're like, yeah, they might be inverses. But there's no real good way to see that those are inverses of each other. The problem with this problem is going to be handling the multiple layers when you throw them in. I got to put this whole thing there and there, right? So if I do f of g of x, I got to put this thing here, and this thing there. I'm seeing way too many people, which is anything more than 0, are telling me that this would cancel. No, right? No. Don't do that. That should be out of your system by now. Well, what can I do then? What do I do whenever I have fractions inside of fractions? Yeah. Personally here, I would just go ahead and multiply top and bottom by LCD. So what do you get here?
2x.
Yeah, the bottom cancels, so you get 2x plus 2 plus
2x minus 2.
2x minus 2, I love it. Over
2x plus 2.
2x plus 2 minus 2x plus 2, I love it. Right, because you just read a negative 2 through there. So what do you get here? You get 4x over 4, good, which is what it's supposed to be, good. Those two did cancel each other out, so they are inverses of each other. You don't actually have to do this both ways. If it works one way, it must work the other way. It's kind of neat. So you don't have to also do g of f of x. It's going to work. Yes, sir?
6b on the practice test, this is 0 of f.
Yes, so somebody asked that earlier. The 0 of f is where what happens?
Crosses the x-axis?
Beautiful. Cross the x-axis, and it otherwise is known as where the output is 0. So just set the function equal to 0. Don't put a 0 into the function. Set the function equal to 0.
Which one are you talking about again?
Number 6b.
Can you do 6E?
6e. E? Yep. So what is that symbol asking for? Good. Here, yeah. So no multiplication here, right? This means f of 2 divided by g of 2. So then you can just focus on figuring out what those are and then dividing them. All right, so you plug a 2 into f, you plug a 2 into g, and then you divide them. Cool. So I can't remember how that goes. Yeah, he just jumped right to yes. And by the way, on the answer key, I'm not showing you the acceptable level of work everywhere. Do you understand? I'm the only person that could do that here. So like 6F, if you give me that, no, you got to show me some work. Right?
We'll write a little paragraph that says how I got there.
Sure. Very little paragraph, because I'm not an English teacher.
Number 30, 2.7.
Oh, okay, so that one's a lot like this one. Right, they ask you the same question. Verify that these are inverses of each other. This is what you're talking about?
Yeah.
Alright, so all I want you to do there is plug one into the other one and show that they do end up with just x, right? And it kind of makes sense it's going to happen, right? If I do f of g of x, I plug this into there. So it'll be 5th root of x to the 5th power.
But then at that point, do we even have to, since it's...
You really want us to write it that way?
Yeah.
Yeah, that's what the instructions
Tell
tell
me,
me.
do you want us to write it that way? If we know that a fifth root cancels a,
Well, then that's quick, ain't it?
yeah, we can just go.
None. Yeah, all
I
right.
have to write all that crap. Or can I just say, yes, it's an inverse?
Poor Ryan dies right here. Come on. It's gonna write so much. No, yes, I do. And the instructions say use this property. So if I don't see it used, I'm gonna have a problem. But yeah, I mean, in general, this one should be relatively easy to see. It's going to be quick because the fifth root and the fifth power obviously are inverses. But this is just verifying that the property is true. If you plug one in,
A lot of paragraphs.
huh?
I'm going to write you a lot of paragraphs.
If you want to, I'll read a few. Yes. No. Anything else?
My question.
Oh, good. All right.
So,
Okay. Anybody come in that wasn't here earlier? Natasha Jones. My trans. I got no trans anymore. D Tran, Van Tran, Zhuzing, Ja, Zhuzing, Ja. Okay. I'll hold one of those.
Yeah.
it's starting.
Oh, there's
So,
I have a question. I thought you were going to.
done. Floor's yours.
8A, on the practice test. So,
8A.
yes.
Okay.
And everything cancels out.
Yes.
It just means all the real numbers. I just wasn't.
If you end up with, in general, when you solve an equation, because this is something I'm assuming you're coming into this class understanding, so I better talk about it real quick. If I solve an equation and I get 1 equals 2, right? You haven't discovered something. Yeah. So in general, if I solve an equation that actually has an answer, if I solve this equation, I'll get x equals 1. So what this really says is, when this is true, this is true. That's what that really says. So then you can apply that to anything else. When this is true, this is true. This is never true, no solution. So of course, if I have one where everything cancels out, minus x, and you can even do -1, -1, it doesn't matter. I either get 1 equals 1 if I don't, or I get 0 equals 0. Both of these statements are always true. So the answer is all real numbers. So it's sort of like the x gets out the way. So it doesn't matter what number you pick here, it matters what else is going on in the problem. I can't add 1 to something and have it be the same as adding 2 to that same thing. That's obviously a bogus equation. And math has to allow for bogus equations, because we have a little tiny here's a little tiny business, and they want to say, Johnson, set up the equations to figure out how we can make $5 billion next month. All right, well, the equation is going to come out with no solution, because there ain't no damn way they're going to make $5 billion next month. Right?
Unless they're Apple.
Huh?
So unless they're Apple.
Sure. Yeah, this is a little tiny company. Apple would be, I don't have enough room to draw that picture. Yeah.
So the same thing, but for more money.
If we sold one item for $5 billion, we could take the rest of the month off. Yeah.
Can you do it's a problem from WebAssign, but they have a similar one in the book, number 82 from it's on page 206.
Okay. 82.
Yeah, 27. It was the last problem on WebAssign.
Coolness.
It was it was like 175. V parentheses T or V function of T equal to 175 was the problem.
Oh, okay. Well, let's do. I'll do this one in the. Let's see.
That was nice.
Oh, that's okay. They're both the same idea. A tank hold. So yours tank hold held 175 gallons of water.
Yeah, that was the other
The tank to empty in 40 minutes. Find V inverse. What does V inverse represent? So
I'm sorry.
what does this represent?
That represents the time it takes to
This represents the.
time it takes for.
No. If you plug a 3 in there, for example, it'll tell you the volume at 3 minutes. So in general, this tells me the volume at some time t. Cool. So now they want you to do the same thing. Now find the inverse and tell me what the hell that represents. And why does this have an inverse? It's a squared function, right?
Because it's talking about actual things.
Positive time and positive volume. So the domain is kind of inherently chopped for physical problems. right? So this will have an inverse. An inverse will exist. You just have to figure out what that inverse represents when you're done with it. And what would it represent? It would be...
Sounds like the time elapsed or something like that.
Yeah, it kind of sucks that I have v inverse of t. That's just stupid. I would actually just solve directly for t. So then you get t as a function of volume. So this will be like, if you say, well, I want to know when is the volume going to be 50. So this would be the time it takes to get to a volume, a given volume. Whereas this is the volume at some given time. You guys kind of with me? So that one says, find the inverse, and then tell me what the hell it means. And then part B is just find, once you find the inverse, which, you can use this. All right, let me see. You remember how I switch x and y to officially find the inverse? For physical functions, I wouldn't switch the variables because the variables represent definite things. You with me? I wouldn't just switch the v and the t because t is time and v is volume. They got to stay where they are. So I wouldn't even recommend doing this. I would recommend leaving them and just solving for t. Then they still are where they're supposed to be. They still represent time and volume. Are you guys kind of with me? Okay, a little bit. So then the next piece just says throw 15 in there. Which would be like I just said. If I want to know how long it takes until it gets to 15 gallons, that's what that would represent. How long do you have to wait until it's down to 15?
Okay.
You're draining this thing out and you're like, I want to go home. How long is it going to take?
Well, it's a leak, but yeah.
Or, okay, so I forgot what the point was. Okay, shoot. Then you want to know how long until
I'm out of water.
Until the gas is everywhere, and then I can light it and go. What's that?
Did you do this while you were drunk?
Oh, yeah. I try never to put personal life into problems, but sometimes it leaks out.
Good on.
Yeah.
When they ask when something is increasing and decreasing, they're referring to the domain, right? So like,
I love it. Because increasing, decreasing is where is it increasing, decreasing, right?
Yeah.
So that where is always the x-axis. So there'll be an interval over the x-axis. So people get a little confused because the function's just kind of like going all over the damn place, and you're worried about what do I look at. But where is it increasing, decreasing is going to be on the x-axis. That's where something happens. The what is the increase, decrease.
Yeah.
So that's kind of given. I don't care about that. I want to know where is it increasing, decreasing. X interval.
Okay.
Yeah.
So when you say the graph, you have a function graph, and you say graph the this part of the function. So modifying it, transforming the function.
Okay.
Is it okay to, I know you said shift left, but if we have the graph and we just say arrow this way too?
Sure, yeah.
Okay. That does the same thing. You're fine with that? We don't have to say reflect and all that. We just be like...
Sure, that's fine.
Okay.
You guys are looking at me so expectantly. I got nothing.
What do you, on your entry key for 7 delta?
7, what's that?
8 delta.
Okay.
In the parentheses, wouldn't there be a negative in there, and then coming out would be a 3i, not just a 3?
Oh yeah, shoot. I meant to put an I there. I forgot all about it. So in part D, 8D should be 3i root 15. You get a negative on the interior. Cool. Yeah, everything else is right. It just has to have an I out there because you get a negative on the inside of the route.
So for clarification, so for like compressing, when it's in with the x, if it's like a fraction, it'd be a.
And yeah.
If it's with the y and it's a fraction, it's a.
If I have, if I'm given a function f of x, and they say, what does f of 1/3 x look like?
Yeah.
All of my inputs now for this. Like, if I want to know how do I get to f of 9, well, it used to be just plug an I in.
Yeah.
Now, how do I get to f of 9? I got to plug a... No, that would be 1, right? Well, what's 1/3 of what is 9? I got to plug out 27 in, right? So that's why this does the opposite of what it looks like, because my inputs have to overcome that. You see what I'm saying?
Yeah.
So since I'm cutting them in thirds, they ought to be 3 times bigger than they were before when I put them in. That's why it would stretch it out, right? Like that one problem we saw with the H that looked like that the other day.
So if it's outside of the
If it's outside, it takes all of the outputs, what they used to be, cuts them down by a third. So when it's outside, it does exactly what it looks like it's going to do, right? So this here would take it one to the right, because x's now can all have to be 1 bigger than they used to be to overcome that -1. But this is going to take it down 1, because it's outside. It's going to do exactly what it looks like it's going to do, because it takes all the outputs, makes them 1 smaller than they were. Good. Yes?
That's a weird question. Could you give us just a group of random problems? Because I mean,
Yeah, I did.
I know you did it, but I'm like, I want to.
Like what kind?
How about simple ones that people just make mistakes on? Like you see, especially like in government. I don't know. I don't want to retake the practice test now because then I'll do like, okay, that makes sense. Okay, that makes sense.
I mean, the most common areas people make mistakes are the absolute value stuff. We need 2 cases. There's just so many different kind of mistakes people make. That's crazy. Let's see what else. There's mostly pretty straightforward stuff here. When I ask for domains, people aren't careful enough on those. You've got to be really, in fact, it's a good area to talk about. If I said, what's the domain of this? If I see you do this, I don't like that. It has nothing to do with the question at all. Sort of it does, but not really. Right? What should I put there? Not equals.
Greater than or
Greater equal to, yeah. Right? If you get equal to and you get the answer, then somehow it transforms into a interval going a certain way. I'm like, how do you know which way it's supposed to go? I don't see that in your work. Right? So there, now I'm going to see it in my work. Add x over, flip it around. If I add x over, flip it around to that. Now, on the heels of that, how would I do the domain of that? It's still the same starting position, right? X squared minus x has got to be. But I can't solve that directly. Pull out an x. And then you need the little number line dude to figure it out. Don't give me 0 and 1 and suddenly have an answer here. Right? If it's wrong, obviously I can take off 1 point. If it's right, I'm still going to take off freaking points because I don't see where it came from. Do you understand what I'm saying? You could have graphed it and just saw where it was something. I want to see by hand, how did you get there? And do you see the difference between these two? This is just a linear. I can solve for x. This has got a square in it. Inequalities are really weird to work with squares when there's there's just no way to really do that directly well. Visually, you can imagine this is a parabola. It's going to be above 0. Can you guys see this? If it's a parabola opening up, it's going to be above 0 outside of its intercepts, right? If you want to go that way, you can draw me a little picture in a little paragraph, and then you can have the answer. But the quickest way to get there directly is to say in 0 of those places. Change this one.
like 1/2.
If I put a 2 in, positive times positive, and it's going to change the sign everywhere because it's first powers everywhere, right? So this is like I just said. Where's the grade equal to 0? Out. And you can kind of see it's positive there, 0, negative there, 0, positive there. That's exactly what it's going to look like, that parabola. But I need to see some kind of work connecting this with the answer. I can't just see the answer, even if it's right. I don't care. The work is more important at this point, to be honest. When you get in the real world, the right answer is important. Right now, the work is what's important. You make some stupid little mistake, but you did all the work right, you have the concept right, you might not even lose any points, depending on what kind of mistake you made. Yes?
You could do 11.
11 D?
Yeah.
Oh yeah, that's a good one. That one takes that problem we had on the quiz and does one little extra level to it. By the way, guys, once I say this, we're going to have a stampede, so just hang on. If you guys are ready for the test, you can head out anytime. On any review day, if you're ready for the test, you can head out. All right. They're all scared to do this one. 11D. So if you look at my answer key before you think about this, it's a little weird how I got to where I got. In fact, it's actually even weirder than what it should be, because I just realized it's a 3, not a 2. I think on the answer key I thought it was a 2. So what do I have here really?
No, it is a 2.
No, that's a 2.
Is it a 2? Oh, thank God.
Well, just the first one.
Okay, that's better. So I did it right. I can't just take a 3 out of here, for example. I can't. Because I don't have just a 3. I have 2 3s. I know I have an A and a 2, but I just want to focus on what's going on here. Right? So what's really here is, you don't have to write it like this. But it's sort of like, I want you to really see this analogy. If I had square root of 9x, how can you rewrite that? Can you take a 9 out? No, a 3 would come out because you take the square root of it before you take it out. So I can't just take a 3 out, I take a 3 squared out. Same idea. Because there's 2 of these things, right? And they each can give me a 3, so I take a 9 total. They each can give me an A, so I take a
A squared.
A squared total. And then what's left?
X minus 1.
Beautiful. So again, if you need to, you can write this down twice. Because that's what that is, right? I get a 3 out of there, and a 3 out of there, so that's why I get a 9. I get an A out of there, and an A out of there, so that's why I get A squared. And then this is x minus 1, x minus 1, which is x minus 1 squared. But if you understand this, I square root it before I take it out. I square it before I take it out. Same damn thing. Same idea. Okay? Because again, squares and square roots, they work really well with multiplication. They don't work well with addition and subtraction because they're not based on it. So it should be that easy to work with that kind of thing. And then I got the rest of it. Now this looks just like the one on the quiz.
Yeah.
3 and 2 A's and how many x minus 1s?
2.
2 of them. So this whole term I have, what do I have left? A 3. Let's took both A's, I took a 3 out, I took both of those, it's just 3 left. Plus 4 cubed. And I got 1 of these left. So then the last step is to distribute that through. I know normally multiplication is the opposite of factoring. I'm done factoring. Simplification is the last thing I have to do. I have to simplify the inside of that factor. Right? You wouldn't multiply these together, that would be the opposite of factoring. But distributing this is just simplifying the inside of that factor. So that's why you have to do that one more step.
And then where did we get that first 3 from on the second part?
9a squared divided by 3a squared is 3. And then both of those are gone. Plus, and then the next term. Cool.
So whenever you pull them out of the square like that, or whatever power it is, you've got to multiply it by that power.
You got to apply that power to it. So if I had 2x plus 2 to the 4th power.
So you have to pull 16.
16. And what's left?
X plus 1.
To the 4th power. Because each 2x plus 2 I pull a 2 out of, right? And each 2x plus 2 would have an x plus 1 left over. And I do that 4 times. So of course I get this. Okay, cool. Yes. So 2 things I want to check. Do you believe me? I have nothing. It's totally based off of what your questions you have. And secondly, if you're ready for the test, you don't have to feel like you have to stare at me. I'm not going to take it personally to leave. Yeah.
Where did they ask him when you say gradually day?
Where are we at?
Number 9.
So
Oh yeah, so what does the unshifted function look like?
Oh,
That's the base function, yeah. Cool. So that's like the dotted line we start with.
the first, I'm sorry,
It'd be the square root of x, right?
Beautiful. Alright.
It's a word problem.
So we got a triangle, the height of the base. And one thing it says is, huh?
Well, it's based on the height. Everybody was like, now.
What's the second thing it says?
The area is 100.
So 120 centimeters square is, 120 equals, good. Solve for H or B and then plug in. And then you get a quadratic, you get a...
For the, found my corrections. Do you want me to go further?